Hi, in the last session, we talked about service-based architecture in 5G core network. Now let's talk about virtualization and understand what is NFV, network function virtualization. Because now we have some basic understanding of cloud computing and virtualization, so we can move forward to explore how these technologies can help in telcos and networking. So let's start. Okay, so first understand what is NFV or network function virtualization. Network function virtualization is the technology that transforms that how the network services are deployed by using softwares instead of specialized hardware. Traditionally, network equipment comes with purpose-built hardware. For example, components like mobility management entity or MME and firewalls, etc. They all are tightly coupled with their hardware. These network functions always come with their own specific hardware, means each function has its own physical device. So upgrades and maintenance are challenging on them. The another challenge with those dedicated hardware is that any provisioning, maintenance and decommissioning are labor intensive as they require physical handling of each device. Now, with the advancements in virtualization, we can now replace these specialized and property-based hardware devices into software-based solutions, and they can run on general-purpose hardware or servers. Network function virtualization or NFV is the process of separating network functions from their dedicated hardware. And after that, they can run as a software on standard hardware or COTS hardware. So the network functions like CDNs and firewalls, etc., traditionally they run on the proprietary hardware, but now they can operate on standard data centers. As you see in this diagram, in the left, we have traditional hardware coupled network functions, and in the right, we see that all these functions are decoupled and now deployed on the general purpose hardware. The software-based implementation of network functions such as virtual MME or virtual firewalls, etc., are known as virtualized network functions or VNFs. In 5G networks, all of these core network functions are designed to operate as VNFs. So they can deploy it with the more flexibility and they are easily scalable based on their demand. This includes critical functions like session management function or SMF, authentication server function or AUSF, unified data management or UDM, and all other components mentioned here. When these VNF are deployed using Dockers and containers instead of traditional virtual machines, then they are referred as cloud native implementation. And these cloud native systems are even more efficient and they are more scalable. Now, before going further, let's understand some background on cloud computing and virtualization. So there are two key technologies that are continuously evolving to manage IT resources. We will understand them with one simple example. Let's say that you need to set up an email server for a company with 500 employees. And we know that load on those servers will not be consistent all of the time, right? Like during the weekdays and in working hours, email traffic will be high. But at the night, it will be very less utilized. Due to this variation in workload, it is difficult to optimize server resources. You can either invest in a server that can handle even more capacity than your peak email traffic, but this approach is not very efficient as most of your resources will remain unused during non-working hours and weekends, so they may not justify your investment. And if you choose a server with a lesser capacity, then of course it will not be able to handle peak load traffic and there will be unused email requests at the time. And there will be potential downtime during those busy hours. Now you can say that what if you match the server to the peak load? Well, you will still face inefficiencies. And another problem is that your peak load can also change over the time as your company grows or shrinks. So that will require adjustments all of that time. Typically, such personal servers are generally underutilized in most of the cases. Even real-world estimate shows that the average utilization is around 5% to 20%. And this type of approach are not very efficient to deploy or manage. Additionally, if your server hardware fails, then the entire email system can go down, which can affect your company communication and productivity. Cloud computing offers a solution to these challenges by providing flexible and scalable resources that can adapt to your needs. So let's understand what exactly is cloud computing. In simple terms, cloud computing is the on-demand availability of computer system resources. For example, computer storage, computing power, networking, etc. And all this flexibility comes with very less human intervention or even no user management to the physical hardware. For example, in our email server, what if that company prefer to have a subscription to an email service like Gmail Enterprise is offering, which provides the necessary resources on demand. This way, that company gets the access to the computing resources as per their requirements, and they do not need to worry about underutilization issue and overcapacity problem. For example, if your email inbox are full, then you can easily purchase more storage space with just few clicks, or even you can automate that with the cloud services. Or if your company expands and you need more email accounts, then you can quickly add more email accounts to accommodate new employees. This approach ensures that you only use the resources that are needed for your requirements and only pay for those resources. So it eliminates both the challenges of underutilization and overutilization of resources. And this is a cost-effective solution as well. Secondly, you do not need to manage hardware by your own. And you do not need to worry about hardware failures or system failures. And even you do not need to invest in the new servers and storage. The cloud provider or the service provider will handle all of these things for you. The cloud provider such as Google, AWS, etc. share its vast computing resources among many users like you. And hence they can avoid or minimize their resource wastage in much better way than an individual company. And it also reduces their cost as well. In a traditional server-based system, you start with the physical hardware as a foundation. Then an operating system is installed on top of this hardware. Finally, you have one or more applications that are running on the operating system. However, in a cloud-based system, virtualization plays an important role and it allows you to run multiple virtual servers on the same physical hardware. So, what is this virtualization? Well, if you look at the second block diagram from the left, this is type 1 of virtualization. Virtualization is a process where we create a virtual CPU, a virtual memory, or even virtual networks from physical resources like CPU, memories, and networking hardwares. You can create and enable multiple virtual machines on the same set of hardware. And these all virtual machines can share the same physical resources. This process separates the logical resources from the underlying physical hardware. So this provides more flexibility on the resource management. In general, you can consider that in virtualization, applications works with the virtual CPUs and virtual memories, etc. And they are treated like they are running on a separate physical machines because their resources are virtually isolated from other machines. In a cloud-based system, you have the hardware layer and on top of it, there is a hypervisor. This hypervisor creates a virtual CPU and virtual storage from the physical hardware. This setup allows you to run multiple virtual machines or VMs on the same physical hardware, and each of them can act like an independent server or an independent machine. And these all virtual machines will have its own operating system and applications. Now, there are two types of hypervisors used in virtualization. If the hypervisor runs directly on the hardware, it is called type 1 hypervisor. If the hypervisor runs on top of a host operating system, then it is called type 2 hypervisor. Even though virtualization is efficient, but these systems can be further optimized. In a virtual machine setup, each VM typically have its own operating system, like Linux or Windows operating system, etc. And if you install a fresh operating system on each individual virtual machine, then it will increase the storage requirement, which is an additional storage overhead on the machine. And when you start a virtual machine or restart your VM, then the operating system will boot up like normal every time. And this can be a time consuming process. To overcome these issues, cloud systems are evolved to use containers, which are more lightweight and efficient than the traditional virtual machines. In this container-based system, your application and all of its required elements like libraries, functions, binaries, everything are placed into a single lightweight container. So this will allow faster startup time and better resource utilization. Additionally, you can run multiple containers on a single operating system. So you do not need individual copies of operating system for each container or each application. So this is the example of cloud native applications, where applications are designed and run as containers, and they are also optimized for modern cloud environments. Okay, so that's it for today. In the next session, we will be talking about different core network functions of 5G. Like we will talk about AMF, SMF, AUSF, UPF, UDM, UDR, PCF, etc. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.